Hi, everybody. My name is Cyrus Clarke. Thank you very much for that very generous introduction. So my talk today is all about how we can reimagine the cloud by storing data nature's way. And I think it's going to be a surprising and hopefully unexpected discovery for many of you today. So to start off with, a little bit about me, because I think it helps to contextualize what I'll be talking about. So I basically operate and live at this intersection of art, technology, and nature. And that sounds very nice. Many of my friends say to me, Cyrus, that sounds so lovely. You get to live and work at the intersection of art, technology, and nature. That must be like exploring a wonderful meadow full of amazing dreams, where the sun seems to hover over the horizon while you discover these fantastic new technologies and possible futures. And I'm like, yes, you're right. It is exactly like that for much of the time. But for a lot of the time, it's also like this, which is not quite as fun. But I kind of accept that because I used to do something quite different. I used to have a job, which was good in one way because I would get a regular income, but it was very constraining. I was working in innovation, and while we were trying to think about how things could be, it was very linear. It was very much focused on how things are and trying to make incremental progress towards what things could be. And while I was supposed to be thinking about 5 years into the future, realistically, I was working on 18-month-long product timelines. So it wasn't very fulfilling, it wasn't very interesting, and I find myself always thinking further into the future. What might be happening 10 years into the future, 20 years into the future, maybe even 50 years into the future? And that was very natural for me. Because I started doing this in my head. I started just exploring these other realms. And my approach today is very much that. It's one of experimentation, where I understand how things are today, but I don't take that for granted. I kind of want to imagine that things can be radically different, and I want to also help to enable that. I want to be part of that change, and I want to be part of that vision. And many people over the years, while I've been doing this, have said to me, Cyrus, you seem a bit of a dreamer. You are a bit in the clouds. And that's quite ironic because a lot of my research in the past few years has been about the cloud. And I guess because it's a dev conference, I don't have to really explain what the cloud is, but I'm going to anyway. And I'm going to do it in my own way, because for me, the cloud is full of contradictions, and that's why I find it so rich as a topic to explore. So what is the cloud? Is it immaterial because it's data? Because data isn't material, it's this stuff that's all around us that we can't touch, but it is there. Or is it physical because data centers and hardware are extremely physical? Data centers are the largest buildings ever constructed. They are enormous constructions of steel and plexiglass, using tons of water, housing all these servers, occupying as much land as the city of Paris if we bring them all together. Quite enormous. Is the cloud full of information because there's a lot of data which is just simply information? If we look at it really objectively, yes. But is that information also an asset? Is that data actually just an asset? Is it really information anymore? And then the last one, which is my favorite, because the cloud, of course, is called the cloud, and when we think of clouds, we think of fluffy things in the sky, which are very nice and benign and cute. But actually, the cloud is quite dirty, isn't it? We're beginning to learn that now. And when I started doing this research, this is not what I'm doing now, this was when I was doing research in 2017, the last one especially wasn't really spoken about. People knew that there was a lot of energy required for data centers, but they weren't really making this link between the energy required now and carbon emissions in the future, and how that implies a huge amount of challenges moving forward as we grow our computing power and computing needs. And so that one in particular really triggered me. It sent me into this more dark world, a more dark spiral, especially this idea of fluffiness. Like, why is it called the cloud? Why is it given this fluffy name? This metaphor seems really not very apt at all. Maybe we should call it something else. And I haven't got a new name for it, don't worry. But when I started looking into it, I was really, really fascinated by this link between the cloud and ecology. And here are some facts which you might already know and are already probably outdated because things are changing every day. But the first one is that the cloud and data infrastructure in general are using something like 2% of our global energy, which is a really significant amount of our global energy. And we'll get into more about why that's significant in a moment. And of course, all of that energy implies yet more CO2, which we don't want. And the last fact, which I found out relatively recently in 2019 or so, when I started working more with companies, is that a lot of this data isn't actually ever used again. We're storing all of this data in the cloud because we think it's going to be useful later, because we think it's an asset that will be used in the future. But so much of it is never used. 60% at the best estimate, could be up to 80%. And that's because the incentives of this whole model are completely wrong. We're incentivized to store data because it might be valuable later. Meanwhile, the energy use and the CO2 emissions are not included in any kind of factor when we're trying to include our strategy. So this seems like a very poor equation to me. And to kind of sum that all up, because it's a very complex theme, I came up with this term called data warming, which I can imagine you see what I've done there. I've taken the word data and swapped it out for global and then added that to warming. So you can understand this effect in a more holistic way. And this is just going to get worse. I'm really sorry, this is very pessimistic right now, but it will get better soon. But the forecasts right now are predicting that all the things I've talked about in the previous slides are just the tip of the iceberg, because things like AI are now growing exponentially. And that means that we're predicting that up to 21% of the world's energy will be going to data centers by 2030. And that's in large part due to AI. And that might be underestimating it, if we're honest. And this is from MIT. This is not from some kind of tabloid newspaper. So this is pretty concerning, right? That's one hand. On the other hand, though, some of my friends have been telling me recently, Cyrus, what are you going to do about this? And I was saying, well, we probably shouldn't just burn all the data centers down. That wouldn't be a good idea. Maybe we can try to do something else. And I've noticed a trend where companies are making a concerted effort to move in a better direction. So Amazon and Google and Meta, they're all going with the sustainability vibe. And I really like that. That's a bit of progress, a bit of green IT. That's nice. Apple, though, going with environment, which I like a bit more. It's a bit more inclusive. It's not just about sustainability. And I think that's actually, even though it's a bit of a joke, it's a little bit important how we talk about things, because is sustainable really enough? What does sustainable even mean? Doesn't that just mean more status quo? Doesn't that just mean we're kind of trying to manage exactly what we have now and keep going with that model into the future and not really making change, but just enabling us to keep going? Why are we not talking about regenerative IT? Why do we keep talking about sustainable IT? There's a reason for this. It's much more convenient and simple to do sustainability than it is to challenge ourselves and think about regeneration and healing the planet while we're developing new infrastructure. But I'm not satisfied with sustainable, obviously. I want to go towards regenerative. So that's what I've been exploring for the past few years. And when I was looking into what could be possible to help regenerate the planet while allowing us to store more data and allowing us to grow more, because that seems to be the thing we need to do as an economy, I came across the original data system. And maybe some of you have understood what that is because of the grayed out graphic in the back. Can anyone tell what that is? DNA. Yay. So yes, it's DNA. And DNA is actually a fantastic data storage system. And I will show you how it works now using the classic tech trope of a dog photo. So we have a photo of a dog. And at its essence, the photo of a dog is zeros and ones, as you all know because you're devs. And those zeros and ones can as easily be translated or transferred to A's, T's, C's, and G's, which are the nucleotides of DNA. So it's just like translating from French to German or one coding language to another. Once we have those A's, T's, and C's, and G's, we can send that to a lab, and they will synthesize that DNA. And once they've synthesized it, they can sequence it and then create lots and lots of that DNA in a droplet of liquid, like you just saw on the screen. So you're going from digital bits, which are relatively immaterial conceptually, to physical atoms. So it's quite a magical process where we're turning data into matter. But why would we want to do this? Well, DNA is actually a fantastic medium when we look at the properties of it. So the first one, which is obviously the most important because it's first, is that it's high density. So what I mean by that is we can store petabytes of data in grams of DNA. Today, we store petabytes of data in kilometers of data centers, which is an enormous paradigm shift when we think about it. It's also incredibly long-lasting. So think about it. DNA's been here for billions of years. It's not going obsolete. I mean, we'll have to destroy a lot of things. We are on our way to do that, but we'll have to do more to get rid of DNA. And that's a bit better than silicon computing, as far as I see it. And then lastly, it's very low energy consuming. So DNA, if kept at room temperature, basically looks after itself, and computers don't do that. So this sounds really good. Just to put it as a caveat though, this is very theoretical right now. It's a very early field. So to contextualize that a bit more, DNA data storage is very, very new. So it's been theorized for quite some time, but being applied only since the late 90s with people working at the intersection, a bit like me, of art and science, like Joe Davis, who encoded this graphic into DNA. Into the 2000s, you have scientists really exploring the theoretical limits of DNA data storage. And that's where we begin to hear these theoretical numbers of petabytes of data in grams of DNA. And that's still being explored today. This is not finished science. It's very, very early. But we're also beginning to see very early applications and even startups using this technology now. And it's still very early, but there's some interesting stuff going on. So for example, one of the scientists I collaborate with, Jeff Nivala, was responsible for encoding the galloping horse you see here, another tech trope, into DNA. And that was the first time that anyone had encoded a moving image file, not only into DNA, but into a bacteria. And when I heard about that, my brain kind of like went, because I was like, wow, that's pretty obvious. I mean, if you could store data in DNA, you could store it in organisms. But there's a lot of organisms out there which can remediate carbon. You've got things like cyanobacteria, which are really, really powerful to remediate carbon from the atmosphere. What if we could store data in those? So I started thinking about that, and I realized that no one really understands cyanobacteria, and it's a bit obscure. But people know about plants, and they kind of like plants. So what if we start to think about that instead? What if we start to think about storing data in plants? Would that be interesting? Would people find this emotionally resonating with them? Could this answer some of the issues we have with data warming? Theoretically, in principle, maybe, but also as a vision, could be also very interesting to explore. So I began to do that, and just off the cusp, off the top of your head, you know that plants absorb CO2, we all know that. So that's already very interesting to begin with. Plants also photosynthesize and create their own energy, so that's great in terms of the data issues we've talked about. And also, plants self-replicate. They create seeds and make backups of themselves. Imagine a computer that makes backups of itself automatically with no energy while absorbing CO2. I mean, that's pretty amazing. If it could also store lots of data, which DNA can. So this, to me, as a non-scientist, sounded really, really good. So I began to explore it. And while I was exploring it, this vision came into my head of switching from server farms, which are kind of really efficient. I mean, I'm not dunking on server farms. Very, very good infrastructure at what they do, but they emit a lot of carbon, use a lot of energy, and they create waste. What if we could switch from server farms to something like a data forest? And I'm using that here kind of playfully as a metaphor, like the cloud is used as a metaphor. I don't literally mean forests of trees where data is stored, or maybe I do. But the vision at least is there. The metaphor is there. The idea that we can have data storage that's actually regenerative and not just doing the things that server farms are doing. Challenging the model that we currently have and have accepted as inevitable for forever. So what I've been doing since around 2018 until now is this, essentially. A process which in retrospect looks quite linear and nice, but was definitely not. But just to make it simple for you all to understand, it really began intentionally with a should we, with a questioning of ethics and principles and values. And once those were ascertained, moving on to the could we, which is normally where we start, right? We usually start with the could we, but I wanted to start with the should we. And then from the could we, as we always do, we move on to the how might we, exploring the possibilities. And for me, this is a really effective way of going through experimentation on new technologies or anything in general. And I'll show you what I've been doing. So in the process of doing that, I also established an organization called Grow Your Own Clouds. You can find that on the internet at growyourown.cloud. It's a research organization experimenting and exploring with clean data solutions, especially through DNA data storage and organisms. So the first thing we did as Grow Your Own Cloud was to create a data flower shop. And the data flower shop was based on a lot of research. It was based on working with scientists to understand how we could store data in DNA, how we could introduce that DNA to plants, what the impacts on the plants would be, and things like that. So there was a lot of groundwork done to establish the safety of working with plants in this way or working with DNA in this way, and everything was kosher and good in that regard. But for me, what was more interesting was to put that into the realm of the public, because the scientists obviously know what they're talking about to some degree, but the public are very terrified. And I use the word terrified of GMOs, because this is what you would be doing. By introducing new DNA to a plant, you're creating a GMO. And when I say that word in Europe, everyone's like, oh my God, GMOs. Terrifying things which are banned by our governments. And I also thought that to begin with as well. But working through this, it became really interesting to see how other people reacted to this particular application of GMOs. So the data flower shop is literally a flower shop, and it was actually made in Copenhagen because I used to live here. So we took over this flower shop, very beautiful one, and you can see lots of nice flowers. But actually, this flower shop was a data center from the future. And you could come here with your data, and you have me, the data growth expert, who's your guide to the world of DNA data storage. And people came with literal files of data that they'd sent to me in advance. I converted it into DNA in front of their eyes, talked to them about what they're doing, and then went through a questionnaire. Do you want your data to pollinate and spread? Do you want your data to live for a long time or a short time? What kind of plant do you want? Sunlight, a lot of water, how much do you care for your plants? All these kind of questions we're going through. And it was great because we had really interesting conversations with people about data, data warming, GMOs, and plants, all by doing this. In the back of the plant shop, we set up a lab. The lab actually featured real processes, but simulated. We performed them. We didn't actually encode the data into the plants as part of the flower shop, but everybody thought we did. So they really believed in this experience. And they left with this really nice plant with a card saying what was stored inside, how much data it carried, how they should care for the plant, whether it was read or write, long term, all these kind of things. And this other guide to tell them how they could look after their plants and how to contact us if they had any doubts about their data care. And it was great because I really expected people to be terrified and everyone really loved it. And then there were queues outside the door and people were just talking about this for ages. And it was very unexpected. I thought this was going to be a small project. I thought it would just be a little flower shop, nice testing ground, make a cool video, move on. And it wasn't. It was something much more complex than that. The response we got was so overwhelming that it showed me that this project gives people hope, and that's so rare to see in this world when you find something like that. So I decided to keep going with this project. They also asked me loads of really funny questions, and I like that too. So they asked me things like this, which you're all thinking immediately. It's like very obvious stuff. What happens when my plant dies? What happens when your computer dies? I mean, it's the same stuff, except your plant makes a seed, right? It's figured this stuff out. When your computer dies, it just creates waste. When your plant dies, it makes backups of itself, multiple backups of itself. And the DNA is also very robust. So obviously, this is not a very good system right now, but it's actually very interesting that people ask this while not asking Apple when they're buying an iPhone. They also asked me this, which is actually more, I think, a more reasonable question. How do we get the data back? Because I had figured out how to get the data in, but at that point, I didn't actually know how to get the data out because I'm not a scientist, and the scientists I'd been working with didn't know either. But it's fine. We have the internet, we have planes and stuff like that, which are bad for the environment. But anyway, I eventually found the right person in the right university who was working with DNA data extraction and sequencing. And he was also someone who'd worked with Joe Davis in the past and liked the idea of making these weird experimental projects, which are not very good for publishing papers or making money, but vision and emotion and so forth. So we began to explore that with him, and that led us to the next piece of work, which is around the could we. Because now we've established that people like it, it's not dangerous, and it's somehow very interesting in a poetic and hopeful storytelling way. But if we could actually do it, if we could actually store data in the plants and then retrieve it, this could be really paradigm shifting for a lot of people, even if it just unlocks something in their brains and in their hearts. And so we built the Data Garden in 2020. So the Data Garden is more of a traditional artistic and technological installation, as you see it here. So it's this nice presented bubble shell garden from the future that was initially presented at South by Southwest, which is a very large tech festival in the United States. And you see plants here, which are, many of them encoded with data in their DNA. It's very, very, very small files that I had produced and created. In the test tubes are samples from the plants, so we've extracted their DNA, and you have data actually in the test tubes. And what's novel here is we could actually take that data and introduce it to a nanopore sequencer, which is a DNA sequencer, which is small enough to be placed within an installation, as you can see here. Very, very nice piece of kit, very expensive at the same time. What you see here is someone very nonchalantly dropping some DNA into the nanopore sequencer and then it being decoded in real time. This is not true. This is just a video. It actually takes a long time, extra processes in the back end, maybe 8, 12, maybe 24 hours to actually make it happen. But the purpose of it here was to kind of dramatize what could be possible in the future. The technology works, it just doesn't work quite as seamlessly as that. But what was really interesting was people saw this video and immediately saw and thought it was real, again, like the Data Flower Shop. And that taught me a lot of things. It taught me that the level of fidelity here is way too high. Probably I should make it look a little bit less real. But also our brains, maybe our human brains now, have become accustomed to thinking that as soon as a technology is in the science fiction realm, it's going to be available tomorrow. And to some degree, that's kind of true. But with this, it's not true. But at the very least, what I was very satisfied with was this actually worked. We stored the data in the plants. We sampled the plants back. We were able to sequence the data back from the plants using the sequencer. So this was huge because no one had really done this before. And it was an amazing accomplishment given that we had started this project as kind of like a creative visionary project with no sense that this was at all possible. No idea that DNA data storage even existed when I began this project. So within 3 years, something really fascinating and magical had happened. And it led to lots of nice things. So I got to talk at a lot of places, which was really good, and shared the vision. We've won some really nice awards, like Science Breakthrough of the Year last year. I got to appear on Netflix, which was really fun. And most importantly, the work itself, the Data Garden, has gone to a lot of places, a lot of art museums or conferences and festivals, and people have been touched by this idea. And I've seen it transform something in them. I've seen them start to think about data or think about nature in a different way. And for me, that's so incredibly rich and rewarding. So that leads us on to the next part, right? What might be? So great, Cyrus, you've done that. You've managed to store data in plants, very small amount of data. That's not interesting at all because we want petabytes and we need lots of stuff happening. We need to run AI algorithms and your plants can't do that. So I've had to find a way to make this interesting because obviously we're in a huge economic crisis and not a good time to be a struggling person at the intersection of art, nature, and technology. So I've been doing a few things. The first thing I've been doing is a lot more research. And thanks to the Data Garden, more people are interested in the work that I'm doing, and they want to explore it further. They want to see what could actually be possible. And so, for example, I recently worked on a project called the Urban Data Forest, which took the metaphor of the data forest relatively literally in the Netherlands. And the city of The Hague was very fascinated to work with this concept and imagine what it might be like if the city of The Hague had various areas of the city dedicated to forests which actually hosted data in them. And they were not satisfied with a very speculative project. They wanted us to work with urban planners, look at actual economic models for the city, and it became apparent very quickly how impossible this would be, because so much of the land in the Netherlands is, firstly, it's very scarce, and then secondly, it's very expensive, and thirdly, a lot of it's just been planned for like 100 years in advance. So very, very difficult to make this kind of intervention in these kind of places. But nevertheless, we managed to do something and plot out these various small areas of forest based on the idea of microforest, which you may be familiar with. And this research is very complex and a bit dense, but I made a video which kind of tries to make it more human. This video shows the experience in the future of two groups of people. One person you see at the top is a visitor to a data forest, a type of data forest called a breathing museum, which is literally a museum in a forest where the artworks are stored in plants and trees. And the second video on the bottom is a data forest worker, basically a future version of myself moving on, being promoted from the flower shop to the forest, if you will. And his story is also really interesting in terms of how he explores the forest in his own way.
I also might find some peace in the breathing museum. It seems so mysterious to begin with. I mean, artworks and trees, they're literally growing data. I initially felt overwhelmed. Did all these organisms contain precious artworks? I scanned a bush and saw a sculpture. A leaf led me to a tapestry. Here, I feel like I'm bathing within nature. I sense myself being immersed and connecting to things which are on the edge of my capabilities. Like, I'm coming just to experience, to be in contact with art in a different, natural way.
I work in a living archive. It's full of all kinds of data these days. This tree has photos from the Gur family. I've helped some of them trace their roots. One of the things that drew me to this life was the vision. The idea of building futuristic infrastructure, but having it function more like a public service than a tech company. In the living archives, we work with local communities to decide what should be stored. Here, we always ask, what should be preserved and what should return to the soil? I feel more like being a forest guardian or a data explorer. I feel myself as part of an ecosystem within the urban setting, which makes it even harder when you see something you feel connected to dying. Yet, it starts to make sense when you understand that in this system, nothing really ends.
Good thing I have subtitles there because it's very bassy. So the data forest project was also very successful in regards of working in a real case, but it was still very speculative, very set in the future, hard to really see how that's going to be happening anytime soon, right? So I've also been doing a lot of work at a more grassroots, or more basic level, human level, let's say, doing awareness, driving like I'm doing right now, working with companies and doing a lot of education as well, working with students to imagine how they could take these technologies and this vision to envision different realities for the future. And working with companies has actually been surprisingly rewarding. Initially, I was quite hesitant, having come from a big company previously. But it feels like people in those companies are a bit agitated and they want change. They want something to happen. They need something to happen. And one of the projects I've worked on recently is with LVMH, which is this enormous luxury group which has a huge amount of data in the end. And working with them, I produced a data kiosk, which is this rather futuristic-looking flower shop based on the kiosks in Milan. And working with a subset of LVMH's most precious data, things like sketches from Christian Dior or architectural visions of the Bon Marché and things like that, or actually the recipe of Dom Pérignon, which is really fascinating to see. Encoding that conceptually into DNA and presenting that as part of this kiosk was really interesting. And we had really high-level people from LVMH come in and want to explore this topic of data warming, of green IT, and how this kind of vision for the future could play a role in their approach to making data more ecological, but also more luxurious somehow. And I think that's an interesting angle, to imagine a future where data storage in this way is more sensorial, and therefore is more luxurious because it's a bit more human somehow. It's more material. There's something rich in that I think is very interesting to tap into. And that's all great. But at the same time, those friends who think I'm having a great time at the intersection of art, nature, and technology, they keep asking me, what about your product market fit? Like, when are you going to translate this into any kind of product or make some money from it? And I keep telling them, well, this is just exploration. It's an experiment. This is 50 years away, if we're lucky. And that worked for a while. But then AI happened, and this huge AI boom happened. And they started coming to me again, and they were like, you said that about AI, you know? You told us it was decades away, and now it's here. I can use ChatGPT, and I don't even know how to code. What are you doing? Stop being so lazy. I was like, I'm working pretty hard. I'm doing a lot of things. So I thought about it a bit more. I was like, maybe there's something I can do. I don't know what it would be. Let's give it a think. Let's just go through the motions. I don't know. Figure something out. So started thinking. Plotted out some quadrants, high impact, low complexity to high complexity. And unfortunately for me, that whole left side is ruled out because everything I'm working with is so high complex. And of course, I want to be a high impact person. I want to really be changing the world and doing those things. But I'm not, I'm actually here. So I'm in the high complexity, low impact realm of technology, which, as I'm sure you can imagine, is a very fun and lucrative place to be. But we have to work with our constraints, right? So, moving forward with those constraints. I have to work with a very small amount of data because the technology is just not there yet. This also has to somehow be valuable, even though it has a very small amount of data. It also has to attract attention. I feel that's maybe a bit more possible, okay? It has to demonstrate the vision, and it has to absorb carbon. Those are givens. Those are things I have to do. And I was thinking about this for a while, and nothing was coming. And then just something came to me from a very, very unexpected place. And the first three, anyway, related to something that I definitely did not connect to this project. And you're going to gasp. NFTs! Oh, gasp and groan and moan, and then vote me down. Yes, at the end of this. But it's true. NFTs use very small amounts of data. They have the possibility of being valuable. They're likely to attract attention, but they definitely do not demonstrate my vision. And they definitely do not absorb carbon. So I was thinking, okay, well, NFTs, non-fungible tokens, they do the first three things. And plants, they do the other two things. So what if I make non-fungible plants? And you laugh, and I like that, thank you. Because it's a joke, but then it became real. And I was like, actually, that's funny, haha. But also interesting, oh. Because if I make non-fungible plants, that'd be the world's first plant-based NFT. And plant-based stuff, pretty hype. There'll be plants with NFTs encoded in their DNA, which is somehow conceptually interesting to me. It can retain its essence as being an experiment where art and nature combine with technology. And we can also shift our paradigm from carbon creating NFTs to carbon absorbing NFPs. So that seems interesting. Let's keep going. How could I do this? Well, let's say I've got an NFT. Grown. Let's make this more interesting. Okay, let's convert that into zeros and ones. It's already better. I feel better about this. That ugly ape is gone, and now we turn it into ATCG, even better. Fantastic. And now that's a molecule. Oh my God, it's physical. But it gets better, right? So that molecule, we can reproduce it many times because science allows us to do that very cheaply. Can you guess where this is going? Ooh. Into the plants. There we go. So our NFT has turned into DNA and gone into a plant. Et voila, a non-fungible plant. But why? Why are you doing this? I mean, yeah, I get it, but it's interesting. I mean, look at this. The materiality of the non-fungible token, very digital. The materiality of the plant, very physical. Already very fun and interesting to me. Carbon emissions high on one side, negative on the other side. Incredible. Energy consumption high for NFTs. We can just cross it out for plants. It's crazy. The storage mediums, silicon DNA, fine, interesting, but we know now that DNA is actually the data storage format of the future because it stores petabytes of data in grams of DNA. We can store metadata in tokens, which is not very cool, actually. We can actually store the file in the plant and in the DNA. You can store databases in the DNA. You can store entire data server farms in the DNA. The tech is also very, very outdated in the blockchain world. Distributed ledgers. I mean, who cares? We've got distributed seeds. Much more cool. And when we're talking about longevity, yes, computers, they last a long time. 10 years, pretty good. Plants and trees can live up to 10,000 years, and the DNA could live even longer than that. So I'm into this. Where does this grow, though? Well, I'm going to be building a garden. It's called the NFP garden, because obviously NFPs are non-fungible plants. And the NFP garden is this wondrous place on the internet, which is like a meadow, which I like to live in. And you also be able to explore that. And you can see some of the visuals from this wondrous world here. The website looks something like this. This is the starting point of the website. I'm not showing you the whole thing. You can explore this 3D world, this 3D garden, which for now has very, very few plants, because we haven't grown many plants yet in the garden. But soon there will be more when you sign up and join the waiting list. And so you've probably been thinking this whole time, what is this plant doing here? And I'll allow you to keep thinking about that, but I just wanted to draw your attention to it. And now back to the screen. We also have a low carbon mode for the website. This is basically the 3D website rendered in low poly and no JavaScript, and we dramatically cut down the energy usage of the website. So what's our growth plan? What's the business plan, Cyrus? How are you going to get this to market, product market fit and all that? Well, we've got a great plan, actually. We've got a pre-seed round, because in order to get a seed, you need a plant. We've got a seed round, because obviously we need a seed round. We're a company. And then we've got our IPO, where we launch to the world in a big way, go to NASDAQ and ring the bell. Except our IPO is an initial plant offering. So the pre-seed, this is already live, by the way. So this is very exciting. I'll actually be launching this from next week, but we can consider this a kind of soft launch here. So the pre-seed is this lovely digital flower, which you see here. It gets better in a second. And you can collect this digital flower to grow seeds in the future. And every collector will be eligible for the next phase of the growth of this project. And the idea of this project is that we grow this together. I don't want to grow non-fungible plants by myself. That's very boring. I would love to have a community of people who are interested in this vision of a different type of data future be part of this project by collecting interesting, cool artworks and then making interesting, cool technologies in the future. Every dollar raised through the collection of these collectibles, it will be matched 3 times as much. So your money will be multiplied, and that's a very good thing in this world. So if you want to collect it, here's a QR code. You can scan it. You can at least look at it and pretend to browse like you're in a shop while I'm talking to you. And you'll receive both the image that you previously saw, as well as the moving video file here, which should have a really beautiful audio reminiscent of angels singing from heaven, but does not seem to be playing, and I don't know why, but it's fine. Have you all had time to scan as yet? I see some people really gradually taking their phone out. There will be further opportunities to scan, don't worry. You missed it. There'll be another one, don't worry. After the pre-seed round, we'll have the seed round. This is where it gets really interesting. So the seed round is using generative algorithms and 3JS, and we're creating unique digital seeds. So this is an initial model based on my wallet address. This is what came out. But each wallet address will generate a unique seed with different shapes and different colors. And that's fun for you. You get to have this nice, cool seed. But what's more important is that we will also collect your address, which is much less threatening than it sounds. Because what we're going to do with that address is create a collective artwork. Everybody who contributes to the seed round will be part of the next phase, which is the IPO. And now you know why this plant is here. Because you can see that everyone's address is inserted into the plant. So my Ethereum address, other people's Ethereum addresses, there'll hopefully be more than 5, because we need more than 5 people to grow the NFP. And what the NFP represents is this collective artwork that we've grown together, the first ever non-fungible plant. It means that everyone who contributes to this will be one with the plant. It goes back to the flower shop where people started to feel themselves connecting differently to nature because they were associated with the data that actually lived inside of the plant. So, another opportunity to scan, just in case you missed it the first time. If you would like to win this plant, this is not the IPO, but this is a proto-IPO. But if you'd like to win the proto-IPO, which is also still very non-fungible, by the way, it will be available for one lucky collector. So if you scan the QR code, collect the flower, you might get some real flowers to give to someone you really like or keep for yourself because you're selfish and you like flowers yourself. So I'll let people scan because it seems like I see people scanning and I want you to have a chance to win the plant. And I still have quite a lot of time. I can't hear you. Oh no, wow, we broke the internet. That's great. I will put the link on my Twitter, which you can also follow at Cyrus Clarke, which you've seen on every single slide so far, so you obviously are following already. But if it's reached the scan limit, that's a great sign. Thank you for shouting that out. So let's come back to where we kind of started. So I was telling you about my story and how I went from how things could be to how things might be, and it sounded very crazy and experimental. And imagine now I'm at this new starting point where NFP is my new starting point, which is a very weird starting point to be at. It's a new experiment. I don't know where it's going to go. It might go there or anywhere. Absolutely no clue. But the main thing I'm trying to do is experiment. I'm trying to put things out there because I know what I'm building has a meaning and a purpose and a vision behind it. So I'm passionate about doing that. And what I think it leads to is this thing called living technology, which is what I'm working on more holistically. And that's also a small plug for my blog called Living Technology, which is available on Substack. And living technology to me is about computing, data storage, and processing that is organic, that works with DNA as its system. And this is something you'll be hearing more about over the next 100 years. It's not going to be something you hear about tomorrow, but it's going to be a technology that I'm going to keep working on for a long time to come. And that's why I kind of want to leave it, because I think for all of us, I really want to imbue that spirit in you to think about how you can go from where you are right now into that mindset of experimentation and building interesting things that I know many of you are already doing because I've spoken to a lot of you, and you're also doing incredible and cool stuff. And I'm really, really fascinated by everything that everyone is doing. But I really, really want to send that on to all of you and share that passion with you to get you to feel like you can do that as well. So if I've gone from having a completely no clue of DNA data storage to now apparently making a non-fungible plant, you can too, even if you don't want to. Thank you very much.